Welcome to our channel. If you're visiting this channel for the first time, make sure you hit that subscribe button. Don't forget to hit the notification bell so that you don't miss any video that we upload on this channel. So today we are looking at symmetric matrix and skewed symmetric matrix. So let's see. So now we want to define what a symmetric matrix is and a skew symmetric matrix. So what are these? So now we are saying that an n by n, simply a square matrix, we define it as A, is called a symmetric matrix if the A of I and j is equals to ji, where I and j is equals to 1 and 3. Now what does this mean? So now what this means is that we're going to define our A, I, j as what? As 1, 2, it continues like that. So meaning this might be a matrix of 1, 1, 1, because this is the first column, so we're going to have a matrix like that. And here we're going to have 2, 1, we're going to have 2, 2, and then here we're going to have, okay, is that the alpha I'm using? We're going to have 2, 3, and here we're going to have, we're calling it alpha, alpha 3, 1, alpha 3, 2, and alpha 3, 3. So now let's just erase that. Doesn't look like alpha, so let's write something that will look like alpha. So we are saying this will be alpha, this is alpha, like that. Okay, so now this becomes our matrix. So now what do we mean when we say ij? This is, it should be equal to that. So now we are saying our A1, this should equal to that. So it should equal to alpha 2, 1. So meaning what we're trying to say is this should equal that, and this should equal that, and this should equal that. So if you see this one going to be A1, 3 should equal to alpha 3, 1. Then this one we're saying alpha 2, 3, alpha 2, 3 should equal to alpha 3, 2. So basically this is what this statement here is trying to tell us. Okay, now we understand that our alpha ij should equals to ji. So if you see where we have the value for I, you can take it as 1 and 1, they are just swapping. So basically this is what happens. Now we continue to say that it is when we transpose our matrix A, then it should equal to just A. I think that was just a mistake here. This equal sign is not supposed to be there. So this is basically what we're going to have. So we're saying if you've been given the matrix A, you transpose it, and after transposing it, your matrix should be equal to the original matrix that you have. So basically this is what is going to happen. So now let's see. We're saying we have a question there. Let's just erase this. We have a question there. It says, show that the matrix is a symmetric matrix. So now we've said actually the symmetric matrix, this matrix that we've been given, we have to transpose it, then it should equal to the original matrix. So the first step that we're supposed to do is to transpose this matrix W. So meaning we're going to have, we have the W, if we transpose it, after transposing it, we're going to have this A, B, 3, meaning this row becomes the column, which is this part, this this row becomes column, this row becomes column. So if you check this matrix after we transpose it, it's becoming actually equaling to the original matrix. So this is how you are going to determine that this is a symmetric matrix. So in the next video, we are going to talk about how we can find a skew symmetric matrix. So here we've said you have to transpose it, but it should equal to a negative of A. So thank you for watching this video. Make sure you subscribe and hit the notification bell so that you watch the next video we are going to post on this channel.